From vaccine deployment in Africa to saving lives on Australian beaches to precision agriculture on farms, wind turbine inspections, and even sausage sizzle delivery to your backyard jacuzzi, drones are changing the way we live and work. My name is Mitch Rudge, and I'm doing a PhD with the University of Queensland Sustainable Minerals Institute, with support from the Australian Department of the Environment and Energy. My study site is the Ranger Uranium Mine, a large, open-cut mine in North Australia, which is surrounded by the World Heritage-listed Kakadu National Park. Kakadu was recently described by our Prime Minister as one of Australia's most important environmental and heritage assets, biggest tourism icons, and home to 60,000 years of living Indigenous culture. Ranger is earmarked for rehabilitation within the next decade, and given the natural and cultural heritage values of Kakadu, the operators are required to establish an ecosystem similar to that of surrounding areas in the park. Ecosystem restoration is growing in scale around the world, not just for mine sites but for other degraded lands, as a way of offsetting biodiversity loss and reinstating ecosystem services like climate regulation, pollination and water filtration. Governments, NGOs and private companies now spend billions of dollars on ecosystem restoration projects. And mine site restoration can be particularly costly, so it's important that projects use recognised standards and rigorous monitoring to ensure ecological return for financial investment. The international standards for the practice of ecological restoration suggest that restoration projects are measured against local native reference ecosystem to provide a benchmark for success and suggest a number of key attributes that should be monitored, including the absence of threats, physical condition, species composition, structural diversity, external exchanges, and importantly, ecosystem functionality. Key ecosystem functions like water, carbon and nitrogen cycling, disturbance regimes, and productivity ensure the long-term resilience and sustainability of ecosystems. For example, in nitrogen-poor environments, atmospheric nitrogen fixing by plants is essential. Without nitrogen cycling, the plants will die. Unfortunately, reliable ecosystem function measurements can be elusive. This is where I think drones can play a part. Stable and reliable drones are now readily available on the open market, and sensors that were once reserved for satellites are now miniaturized and can be integrated onto drones. To measure the ecosystem function of the Kakadu woodland surrounding Ranger, I'm using equipment including this LiDAR scanner fitted onto a DJI M600, which can provide us with a very high resolution 3D model of the ecosystem. This can tell us about demographic and disturbance processes such as the rate of tree death and the effect of wind events. Right now, I'm establishing my methods for data collection, calibration, processing, and analysis. I hope the methods I develop will lead to better restoration outcomes for both Ranger and other restoration projects into the future. Biggest tourism icons and home to 60,000 years. Oh, you killed me! Oh,
I'm so sorry.